Hello everyone, it's me Arvind catching you on another Math Tutor Edu's lecture video. Okay, in this video, I'm going to cover a new subtopic within the Form 4 Chapter 1 functions, which is none other than the composite functions. Okay, so without further ado, let us begin our lecture video now. Okay, from here, let me draw a set of an arrow diagram which indicates a function. Okay, one. Okay, let me draw another one. 2. Okay, and let me connect these two the two oval shape with an arrow F. Okay, if you see this case, you can write your function as fx. Okay, this is a normal function, okay, which by right now you should be know. Okay, let's say if I write here g, okay, so this function will be a gx. Okay, so let us proceed to the composite function concept now. Okay, so what I'm going to do now is I'm just going to copy paste this, okay, and paste it over here. Okay, let me move this. Okay, and let me draw another set of oval shape which indicates that there is going to be another function. Okay, so let me draw a second arrow here which you have letter F. Okay, so this is how a composite function looks like. Okay, basically it's just a combination more than one functions being mapped into one another. Okay, so this is the example of a composite function. You can explain in terms of arrow diagram, or you can write in terms of the mathematical equation as well. Okay, so if I want to explain this in terms of the mathematical equation, so it will be fgx, not gfx, guys. Okay, I'm going to explain to you why in the upcoming explanations. Okay, so in order for you to explain this set of composite function in terms of the equation, so it will be fg x. Okay, you might be thinking, you have g and f, why it's not gfx instead? Okay, so one thing you should know, you come across with gx first, so your gx will be the first function, will be placed at the left hand side. Okay, once you completed the gx, so this gx will be mapped into the function f. So that's why you have the composite function of fgx. Okay, so this similar example, okay, let me show you over here. Okay, let me just copy paste. Okay, over here. Okay, let me just remove this extra line. Okay. Okay, instead of gf, so let me swap the letter. Okay, you write f and g. Okay, so in this case, your composite function will be gfx, because you come across with the fx first, then only you going through the g. So this fx will be bring to the function gx. Okay, I know you won't get it. Okay, I'm just showing you how the composite function may looks like. As you expose into the examples, you will understand this better. Okay, let me show you one last example regarding this arrow diagram before we move on into the example. Okay, so let's say, so let me draw a 4 set of oval shape. Okay, 1, 2, 3, okay, and the last one, 4. Okay, you have here, okay, draw an arrow here, you write the letter F. Okay, draw an arrow here, you write letter G. Okay, and you connect the arrow, okay, and then you write letter H. Okay, let's say the question asks you to form a composite function where it maps function f directly to the function h. Okay, from here you straightly connect to h. So how will be the composite function looks like? Okay, so it will be f x, okay, and then followed by g, okay, and then only you will followed by h. It will be in a reverse direction. Okay, so let me repeat again. So if you still don't get it, okay, you first come across with f, so you write over here fx, okay, and then this fx will be carried forward into gx, so you write beside the left hand side of the fx, so you write here g, okay, and then the information of gfx will be carried into the function hgfx. Okay, so this is how your composite function works, guys. Okay, so this is an overall idea on how a composite function may looks like. So it's basically just a function is written inside another function. A function is written inside another function. Okay, so enough of the explanation. So let me jump into the example. Okay, so let me give you some practical example, guys. All right. Okay, so let's say, okay, let me write here example 1. So let me underline this. So let's say you have fx, okay, is equals to x plus 1, okay, and then you have gx is equals to 2x plus 1 over 3. Okay, so let me underline this, the fraction line. Okay, so there is a difference between fgx and gfx. Okay, there are a difference, guys. So how can you prove there is a difference? So I'm going to show it through the example over here. So the first, what you're going to do is we're going to find the fgx. Okay, so let's say the question asks you to find composite function fgx. So how are you going to solve? Okay, very simple. So start with the right hand side and then you move towards the left hand side. Okay, so the function f you write, okay, you have the function gx over here, right? So function gx is already given here is 2x plus 1 over 3. Okay, so what you do, you just write it over here, 2x plus 1 over 3. Okay, so and you underline the fraction over here. Okay, until here it's pretty easy. Okay, but then from here, how to move to the next step? So your function gx, you already write here is 2x plus 1 over 3. Okay, remember guys, in the composite function I do mention that this gx is being mapped into the function f. So what does that mean? Okay, you see here your function fx, it's mentioned that it is equals to x plus 1. So that means your 2x plus 1 over 3 will be mapped into this x over here. Okay, so if you don't know, no worries. Okay, let me show you the working over here. So from here, so instead of writing x plus 1, so from here it will be 2x plus 1 over 3 plus with 1. Okay, so you substitute this 2x plus 1 over 3 into this x, so you map inside their x. So that's how the composite function works. Okay. And then, okay, from here you just solve them using the normal algebra expansion. Okay, so from here 2x plus 1 over 3, okay, and then you plus with 3 over 3. Okay, since this is 1, okay, you want to make it same, so since you want to combine the fraction, okay, so 3 over 3, okay, and then you combine these two fraction into one single fraction. So from here you get 2x plus 4 over 3. So this is your fgx. Okay. So I hope you can understand the explanation. So this function gx is basically mapped into the function fx. Over here the function fx is x plus 1. Okay, let's say for example if I write x squared plus 1. So how it will be? So similar, 2x plus 1 over 3. The only thing is you just add a square and then you plus with 1. That's it. Okay. Excuse me. So from here let us proceed to the gfx. Okay, we have already seen fgx. So let us proceed to have a look of composite function gfx. Okay. So from here let us proceed to the part B, gfx. Okay. So from here, okay, you must know what is the function fx. It's given that function fx is x plus 1. So what do? You just substitute over here, g in a bracket, x plus 1, close bracket. Okay. For the next step, what do you do? So this x plus 1 will be mapped into the function g. Okay, so where is your function g? So it's given that your function gx is equal to 2x plus 1 over 3. Okay, so please be careful over here. So from here, okay, in a bracket, 2, okay, in a bracket, x plus 1, close bracket. So 2x, instead of writing x, so you map the function f into the function g here. So 2 in a bracket, x plus 1, close bracket, plus with 1 over 3, close bracket. So I hope you understand the concept behind this, guys. Okay. So this function x plus 1, I mean the function f will be mapped into the function g over here. So it's being mapped into the function g. Okay. So from here, you proceed to solve this. Okay, 2 times with x plus 1. So from here you get 2x plus with 2. Okay, and then you plus with 1. Okay, and then you divide with 3. Okay, so you calculate this. So from here you get 2x plus 3 over 3. So this is your answer for gfx. Okay, so from here we can make a conclusion that function fgx is not the same as function gfx. They are not the same, they are totally different, guys. Okay, so that is the explanation which I'm trying to tell you by giving you the example. Okay, and one more thing I would like to tell you. So in the question they may give you like this, f g colon x, okay, in an arrow such that you have 4x plus 7. Okay, it is basically just the same as this, fgx equals to 4x plus 7. Okay, so just I wanted to tell you this information. Okay, and I would like to show you one more example. So let's say you came across with this example where they ask you to find f square x. So what does this means? So this means that your function f is being mapped 2 times. Okay, it's being mapped 2 times, guys. Okay, so from here what you're going to do is this f square, we're going to break it such that it becomes f x. Okay, and then from here let us continue. Okay, so f in an arrow, I mean in a bracket. So your function fx in this case is x plus 1, close bracket. So since your function f is being mapped for 2 times, so this x plus 1 will be mapped into the function f again. So x plus 1, okay, and then you plus with 1. So from here you get your f square x is equals to x plus 2. Okay, so let me underline the solution for the part C. Okay, so let me proceed to the one more set of example. I mean within the one big question, so there are 4 sub question, right? Okay, A, B, C. Let me show you one more one. Okay, g square x. So it's similar. That means your function g is being mapped for 2 times. Okay, let's say for example, what if you have g3x? Okay, if you have g3x, that means you have g, x. That means your function g is being mapped for 3 times. Okay, it's based on the power number here. Since you have 2, it's being mapped for 2 times. If you have 3, it's being mapped for 3 times. Okay, so I hope you understand the concept here, guys. So from here, since it's mapped for 2 times, so I write here g x. Okay, so this gx, so from here you know that the function gx is 2x plus 1 over 3. So let us copy it down. So function g in a bracket 2x plus 1 over 3, okay, close bracket. Okay, and then this 2x plus 1 over 3 is being mapped again in the function g. So let us continue. So it's a bit tricky now, so please follow up with me, guys. Okay, so from here 2 in a bracket 2x plus 1 over 3, okay, and then you plus with 1 over 3. So this function g is being mapped again in the function g. Okay, guys, so that's why instead of writing 2x plus 1 over 3, you write 2 in a bracket 2x plus 1 over 3, close bracket, plus with 1, and then you divide the whole thing by 3. Okay, so let us solve them one by one. Okay, this one you times in. So from here you get 4x plus 2 over 3. Okay, and then you plus with 1 over 3. I know it's a bit tedious, but this is how it works, guys. Okay, so once you solve this, okay, and then you proceed with the addition. Okay, no worries, I'm going to show you the step by step so you won't miss. So from here 4x plus 2 over 3, okay, and then you plus with 3 over 3. Okay, since it's 1, so 3, so you make the denominator same by you times the 3 over here, and then you add a denominator. Okay, when you times the numerator, you must times the denominator as well. Okay, and that's how you have the 3 over 3 here. Okay, 3 divided by 3, you get is 1, right? So that's how you're going to combine, guys. Okay, so from here you divide the whole thing by 3. Okay, so you solve the top part, so you get 4x plus 5 over 3 okay, close bracket, and then you still need to divide the whole thing by 3. Okay, it's for the teaching purpose, guys. Okay, so if you are expert, you can sum up this step, you can just straight away omit, guys. But then if you still don't know, okay, no problem, you can give a long working. So from here 4x plus 5 over 3, since this is a division, you change into a multiplication, okay, and then you times with 1 over 3. Okay, it's the fundamental concept of fraction, guys, of the division. So you change into a multiplication. Okay, so you times in, By the way, it should be 9 guys, not 6. Okay, I was made a mistake. So 4x plus 5. Okay, and then you divide with 9. So this will be your answer for the function g square x. Okay. So if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and not forget to share this video. Thank you everyone for your support, and I'll see you in the next video.